going to set up number 21 real quick. Talks about a guy who invests in a 3D printing company. He invests $6,000. He's earning an interest rate of 7% per year, but it's compounded continuously. Right? And one thing I've seen some of you start doing is make sense of which model would make sense for which situation. So I love that. Keep going. We're supposed to write a model and then use our model to determine how many years it will take for Travis to double his investment. So first of all, we're using A equals PE to the RT. That is our continuously compounded interest equation, which says that the amount of money that we have is equal to the principal, the number we started with, times E to the rate. Remember, E is just a number. R is the interest rate as a decimal, so 7% is 0.07 times T, the amount of times, or the amount of years we've been doubling in this case. No, not doubling, times 7%. Alright, so there's your equation. That's the first question. The next question is, how long will it take to double? There's a couple ways you can think about this. Hopefully you'll start to see this pattern, and I'll just show you the pattern. What is double 6,000? It's 12,000. So that's the amount we want to end with. We want to end with 12,000. Well, look what happens when I divide by 6,000. How did I get to 12,000? I multiplied 6,000 by 2. So when I divide that number by 6,000, I get 2. Okay? So the doubling time is always going to take this form with these equations where you have 2, because I want to double, equals E to the rate times time. And then you just are going to switch this thing into log form. So we do, the base of our exponential is E. And so a way you could think about doing this, natural log of both sides. See how the natural log's with the 2? Okay, so the base of the natural log is E of 2 is equal to this exponent, 0.07 t. Then we divide by 0.07. We get t is equal to natural log of 2 divided by 0.07. And you can just leave it at that. That's the amount of time it'll take us to get to 12,000, or Travis to get to 12,000.